Hello, my dear students. How are you all? Am I audible? Please let me know because I'm not getting any response from your side. So just please let me know whether uh, my voice are clearly audible to you or not. I hope that is audible. Okay, great. Good evening, Gopal. What about others? Why you are not interacting to me? Gussa ho, isn't it? How are you all? Jay Prakash, excellent, audible. Okay, great. So great, excellent. So as you know that uh, the IMS GATE Academy has initiated uh, one very good thing, that is GATE score booster session. How are you, sir? JP? Okay, I'm fine, absolutely fine. What about you? Okay, eagerly waiting for your class. Thank you, JP. So definitely I will make sure that you will going to enjoy each and every second of this session. Okay, so anyway, moving ahead, what I was discussing that the IMS Academy, the IMS GATE Academy has initiated one very good session, that is GATE Score Booster, and this is only to help the student to score their marks in a good manner. Okay, so if you have attended the past session, means this the GATE Score Booster session has already started few back days. So I hope you all of you have attended the session. How many of you have attended the past session, whether it is digital, mathematics, control? How many of you have attended? Please let me know. And also one more thing, please mark your attendance by liking or by hitting the like button. Okay, that will definitely going to motivate me as well as you. Okay, so this session is basically belong to those students who are willing to strengthen their marks, or who are willing to boost their marks just by revising all the concept through the question. Am I clear? So if you have already attended those lectures, then definitely you are knowing that this session is probably to boost your concept as well as your marks. So if you have not gone through, or if you have not yet revised the syllabus, then please do not get worried, that IMS GATE Academy always care for you. So we always stand with you and we always care for you to get the marks in a good manner. Okay, Nikhil sir is the best. Thank you, Saurav. Okay, so moving ahead, as you know that behind me there is one subject which is measurement, and this is session 1. So here basically this measurement subject will going to conducted in 2 sessions. The first session will going to be conducted today itself, and the next session will be tomorrow. So in the measurement subject we have overall 10 chapter. Okay, so the first 5 chapter, or you can say the first 4 chapter, I will discuss today, and the later chapter or the left over chapter we will discuss on tomorrow. All right, and mark my word, whatever question I have, or I have taken, or I have framed, definitely you will going to get at least 1 or 2 concept question from GATE means in GATE 2023. Definitely, this is my word. Okay, so I want each and everyone to please participate in a good manner and in a competitive, healthy manner. So one request from my side, if you have not yet shared this session, please share this session with your friend and with your student community, so that they can also join the session, and we will going to have a healthy session between this 6 to 9 p.m. Okay, so those who have not yet shared, please share among your community. All right, and also please if you have not yet subscribed to our YouTube channel, then also please subscribe, so that you will going to get notified by the session which we are going to be conduct in the upcoming days. All right, so shall we start? How many of you are eagerly waiting? As Jay Prakash is waiting very eagerly, so I am expecting that all of you are also waiting eagerly to start the session. So how many of you are eagerly waiting? The likes are very, very less. Please, this is a kind of request from my side. At least I want my student to like the to hit the like button. Okay, this is for my self motivation. Okay. Anyway, moving ahead. So this measurement subject belongs to two streams, instrumentation stream and the electrical stream. The electrical stream is probably having the marks or weightage, you can say, in the GATE exam, which is varying between 2 marks, or in the some cases it will go beyond to the 4 marks. Okay, so the range of the measurement subject for the electrical stream is 2 to 4, or even in the worst cases it is going to be 5. Okay. But for the IN stream, this will going to be a very high weightage subject, you can say. High weightage means the measurement subject can be framed by combining the subject which is transducer, or you can say the optical instrument. So because of those two subjects, the IN student will have a higher weightage when compared with the electrical stream. Okay, so the weightage which is going to be vary for the IN stream from the measurement subject will be from 3 marks to 6 to 7 marks, like that. Okay, so this is very, very important if we talk about the measurement subject related to the IN stream. Okay, but I want my EE student to please do not get worried about, sir, our weightage for the measurement is very, very. My dear student, the whatever concept of the question I have taken, that will going to cover your network syllabus. Okay, and the control syllabus and the power electronic and many more. So I have combined many subject and I have framed one question so that we will going to cover all, means maximum kind of syllabus. Okay. Ankit Dongrial, big fan, sir. Okay, thank you, Ankit. Sir, eagerly waiting of the session. So let us start the session with the very first question. Okay. So this is the chapter 1 which I will going to cover, the basics of measurement and error analysis. So this is the chapter 1. Okay. So this is the these are the important topics. These are the important topics where the GATE authorities are have been framing the question from the past 20 year or 30 year, you can say. So these are the important topics which we need to focus, or you need to focus during the GATE exam. Okay, while preparing for the GATE exam. So these are the topic. Okay, now let us move ahead with the first question, and for that I will going to give you some amount of time, let us say 1 minute or 2 minutes, and in that 1 or 2 minutes I am expecting you to solve the question and give me the answer. Whether the answer will be correct or not, it will not going to matter to me, because I want only the concept, means how you are approaching the solution. So first I want you to please be ready with the pen and paper and at least give a try. Okay, so let us move ahead with the first question. How many of you are eagerly waiting for the first question? Please let me know. Are we ready to take the first question? I'm not getting any response. Please guys, please let me know. Okay, eagerly waiting, Pratik. Okay, great. Let us start with the first question. So here come the first question from the chapter 1, which is this one. Okay, so this is basically MSQ, multiple select question, where more than one option could be correct. Okay, so see this question, read the question very carefully and try to identify the hidden concept and try to solve the question. Okay, so I will going to give you the 1 or 2 marks. Basically, let me give you the 2 marks for this question, and I want everyone to respond regarding this question. Okay, so let me set the timer for you. Okay, let me read the question first for you. Resistance R1 and R2 have nominal value of 10 ohm and 20 ohm and the tolerance of plus minus 10% each. The possible value of resistance in ohm for parallel combination of the R1 and R2 is R. So from here you can also come to know that this is an MSQ type question. Okay, so let me give you the time for you, a 2-minute time. Okay, not more than that. Okay, give a try fast. Saurav Upadhyay, sir, give give more time. Saurabh, this question can be solved within 1.5 minutes. So I have given you 30 seconds extra. Do it fast. If you want, I will give, but as of now, please let me know the answer at least. Whether it will be wrong or right, it depends on you. But as of now, just give a try to this question, okay? Give a try fast. Doing, sir. Okay, great. Option C. Pratik is saying option C. All right. So I hope you have solved the question and you have marked the answer after that. You are not playing the KBC with me, isn't it? Okay. All right. So if you want some more minute, please let me know. I will give you some more minute for that. All right, sir. This is very, very basic question. Means if you see the frequency of the question in the GATE exam, then from this chapter, definitely this sort of question will have a higher number of frequency or probability to come the question in the GATE exam in the 2023. Definitely this question will going to have in your GATE 23 paper. Saurav is saying 6, which is option A. Do you want some more time? Okay, let me give you one minute extra. Just a second. 1 minute more. Great, excellent. Give a try. You guys are doing very great. You can solve. Okay. So I hope all of you have tried and solved the question. Now let me solve this question and identify the concept that why you have not get the correct solution or the correct answer. Okay. Basically, this question is very, very basic, and if you know the formula, then definitely you will be having the answer within a 30 seconds. This question can be solved by using two methods. The first one, conventional one, and the second one, the shortcut method. Definitely, I will solve this question with a two approach. First, we will see the conventional method, which is a exact method, and after that, I will use the shortcut. Okay, so see here. Okay. So this resistor R1 and R2, will have a nominal value of 10 ohms. So nominal value means what? This is a mean value or exact value. So R1 is what? 10 ohm plus minus, and the tolerance is 10%. 10% means R1 will have a tolerance of 10% and R2 will also have a tolerance of 10%. So plus minus 10%. So this R1 is represented in terms of relative manner. So in the relative, any function can be represented as R1 true plus minus percentage del R1. Okay. Now this is a relative thing in which we can write your variable. Now A and D. Yes, excellent, JP. The A and D is the correct are the correct option for this question. Excellent, JP. Excellent. Now coming back to the question, this R2 will have also the value as 20 ohm plus minus 10%. Okay. So this R2 can also be written as R2 true plus minus percentage del R1. Del R2. So this is represented in terms of relative manner. Now this should be converted into the absolute manner, because whatever formula we are having that are given in terms of the absolute expression. Now see here how we will going to convert this R1. This R1 true basically is what? 10 ohm plus minus. What is 10% of 10? Is 1 ohm. So this value is what? R1 true plus minus del R1. Now coming to R2, this R2 is what? 20 ohm plus minus. What is 10% of 20? This is 2. So this is R2 true plus minus del R2. Okay. Now any values just a second. Okay, now if you want to find the error, basically we need to find the error now, that is, acha, it is not visible, change the color. Okay, let me change the color. Let me choose this red one. Okay. Is it fine now, Gopal? Okay, now the error in parallel combination is given by, see here, is given by, let this error be del R. What is R? This R is a parallel combination. This R is a parallel combination. So this R is equal to R1 parallel with R2. Is it visible, this green one? Okay. So this parallel combination is what? R1 into R2 upon R1 plus R2. Great. Now what is true value here? The true value of the parallel combination. This is R1 true into R2 true, R1 true plus R2 true. So what is R1 true? 10, R2 true 20, R1 plus R2 true is what? 30. So this is equal to 6.67 ohm. Am I clear? Now this is what? This is the true value of the parallel combination. Now if you want to find the error in the parallel combination, which is del R, then this is given by, now see here everybody, this is very important expression which I am going to write. This is plus minus. Now see here, how many variables we have here? How many independent variables we have? R1 and R2. So we have two variables. So what we need to do? We need to partially differentiate R, the parallel combination, with respect to R1 and individual error in R1, and take the mode of it, that is modulus. Am I clear? Now next, plus, what variable we have? R2. So partial derivative of R with respect to R2 into del R2, and take the mode. All right. Now differentiate this R with respect to R1. So once you do that, you will going to get this value. See here, I am going to write directly, and assuming that you know how to differentiate or partially differentiate any function. So if you partially differentiate this R with respect to R1, so other variables will now become constant, means R2 will become constant. So once you do this, this del R by del R1 will be equal to R2 upon R1 plus R2 whole square into del R1, and take the mode of it. Done? Plus, now partial differentiate R with respect to R2, it will become R1 upon R1 plus R2 whole square into del R2. Okay, just a second, let me change this color. Okay, great. Now see here, what is R2? What is R2? Should we need to take the error value or the exact value or the true value? Here this R2 is what? This is true value. So R2, the true value of R2 is what? This is 20, and R1 plus R2 is 30 whole square, and error in del R1, which is 1 ohm. Okay. So 1 plus, and the magnitude of this. Similarly, in R1 we have 10. R1 plus R3 is what? 30 whole square into error in del R2 is 2. So once you're going to solve this, this will become, see here, 4 by 9 into 1 mod plus 1 by 9 into 2. Done. So once you solve this, this will become plus minus 6 by 9. This is 6 by 9, which is 2 by 3 or 0.67 ohm. Any doubt in this till here? Any doubt in this? Do we have any doubt? No? So let us move ahead. Now this R, the parallel combination, this R will be represented as R equal to R true plus minus del R. What is R true? This we have calculated, okay, 6.67 plus minus del R is 0.67. So this value is what? 6 ohm to 7.34 ohm. So with this a type of tolerance, whatever tolerance is given to us, with this tolerance, the parallel combination will have a value from 6 to 7.35. So let us go back to the option and check in which option we are getting the value between these ranges. Okay, so 6 ohm and this 7. So this 6 and 7 will lie between these two ranges. Am I clear? So the correct option for this question is option A and D. So excellent JP, only one student has given the correct answer for this question. Excellent JP, excellent. So I am seeing that your concept is very, very clear. So how many of you have got this concept? And do you want shortcut for this? Alright, so this is basically, you can say, this is the conventional approach in which if you're going to apply this method in the GATE exam, definitely you will be having the exact answer at your fingertip. Am I clear? So let us move ahead with the shortcut method here. Move ahead with the shortcut method. Let me write here method 2. Okay, shortcut. Now look at here. What we need to find? We need to find the values or the ranges of the resistor. Okay. So the parallel combination of R is given by R1 into R2 upon R1 plus R2. Isn't it? This is the parallel combination. Everybody please look at the board, because if you lose the concentration, definitely the thing will going to above your head. So please keep your concentration at the board. So this R is what is a parallel combination. Now if you want to find the minimum value of the resistance, if you find the minimum value of the resistance, what you need to do, please do not say that sir we need to differentiate. No, this we are not going to do. Anyway, if you differentiate, you will going to get the answer, but that will become a very, very lengthy. I am giving you a shortcut method. Now look at here, for the minimum value of R, what you need to do, this R will only be minimum if your numerator is minimum and the denominator is maximum. So if you are thinking that, so take R1 as a minimum and R2 as a minimum in the numerator, and in the denominator R1 maximum and R2 maximum, then we will be having the minimum value of the resistance. But my dear friend, you are wrong. Why? Because at a time you cannot have a R1 value as a different. You cannot have two values at one particular expression. Okay, so whatever resistance R1 value we need to take is basically one value. So for that, how we will going to take this one? How we will going to sort out this one? Now see here, what I will do. I hope this concept is clear, na? If you have doubt, then please let me know. So what I will do, I will divide R1 and R2 to the numerator and the denominator. Okay, so this will become 1 upon, divide this R1 and R2 in the numerator and denominator, it will become 1 upon R2 plus 1 upon R1. Now see, the R1 and R2 now become independent from the numerator. Okay, so this R minimum can only be possible if your numerator is minimum and denominator is maximum. And denominator can only be maximum if R1 and R2 both are minimum. Am I clear? Any doubt in this? Please let me know. So this value, it can only be minimum if your R1 is minimum and R2 is minimum. Okay. So what are the values of the minimum, what are the values of R1 and R2, which is minimum value? So see here. From here, R1 to, this one. Here R1 will have a range from 10 minus 1, 10 minus 1, 9 to 11 ohm. And R2, this is 18 to 22 ohm. Okay. So this 9 is minimum of R1 and 11 is a maximum for R1, and so on so for the R2 as well. Okay. So the minimum value is 9 and 18. So let us move ahead. 1 upon 9 plus 1 upon 18. Okay. So when you solve this, this will become 9 into 18. Take the LCM, and here 27. So 1 by 3. So this will become 6 ohm. Am I clear? So this is the minimum value that we will be having for the parallel combination. Moving ahead with the same concept for finding the maximum value in parallel combination. So R maximum, this will be equal to what? 1 upon 1 by, this time this R1 and R2 will be minimum. Sorry, R1 and R2 will be maximum. Then only this will become maximum, na? Plus 1 upon R2 max. So what is maximum value of R1? 1 upon 11, I guess, plus 1 upon, this is 22. So let us solve. This will be 22 into 11 divided by 33. So 1 by 3, 22 by 3, this is equal to 7.33 ohm. Am I clear? Now if you look the range, sorry. So if you look the range, this R will have R true plus minus del R. This we have, but we have already taken this del R in terms of their minimum value. So the range of R will be, see here, your range of R will be 6 ohm to 7.33 ohm. This is what we have got. This is what we have got. See here. Okay. Now with this range, we will be going to have our answer as an option A and D. Any doubt in this? Please let me know, guys. Any doubt in this? Have you got the concept? Because what the next question will be going the next question we will going to get is from the similar concept. How many of you have got the concept? If you have not got, please let me know. Oh, आग लगा देंगे. Yes, it is like that only. आग लगाना ही है. Okay. So shall we move ahead with the next question? Here comes your next question. Okay, so this is MCQ type of question. All right. So the concept that we have discussed in the last question, the same concept we will going to use. Okay. So for the given network, the measurement inductors L1 and L2 have the tolerance of plus minus 10%. Am I clear? On their nominal value. Nominal value means what? The actual value or the mean value or the true value. If the bus current is 20 ampere plus minus 1%, which is RMS, the minimum RMS current through L2 here, considering the inductor tolerance is rounded to nearest integer. So whatever answer you are supposed to get, that should be rounded to the nearest integer. Okay. So should I give you some time? Okay, let me give you 1 minute for this question. 1 minute for this question, and I want you to try this question with a shortcut method. Okay. So let me give you that 1 minute time. Do it fast. This question is very, very simple, and the concept we have already discussed. We had already discussed the concept. Okay. So use the shortcut method. Okay. Saurav is saying option A. Let us see, Saurav, whether your answer is correct or not. Why others are not participating? I want each and every student to please get involved in the session. Okay. So for the given network, this kind of data we have given. All right. So let us solve the question here. L1 is given as, let me solve here itself. This L1, this is what? 20 millihenry plus minus 10%. So this is what? This is given in a relative. Let us convert in the absolute. So 20 millihenry plus minus 10% of 20 is what? 2 millihenry. So this value, let me change the color for this pen. Okay, so this is what? This is L1 true, and this is plus minus del L1. Am I clear? Now moving ahead with the L2. L2 is what? This is 5 millihenry plus minus 10%. So this will become 5 millihenry. 10% of 5 is what? 0.5 millihenry. So this is what? This is L2 true plus minus del L2. Done. And one more thing, we have error this time is given in the bus current. Okay, in the bus current. So here I bus, which is 20 ampere plus minus 1%. So 20 ampere, 1% of 20 is what? 0.2 ampere. Am I clear? Am I clear? Any doubt in this? Now we need to find the inductor current which is flowing through the L2. So let me take the inductor current as I2 here. Inductor current I2 here. And this is a bus current. So this is basically what? This is basically a parallel combination. This is what basically parallel combination. And we can find the I2 directly by using the current division rule. So how are we going to find the I2 value? This I2 by using current division rule. Okay, this I2 will be equal to what? Total current into opposite, which is L1 by sum. Okay, done. Now what we need to find? We need to find the I2 value which is minimum. Okay, so for that let me divide numerator and denominator by L1. So this will become 1 plus L2 by L1, isn't it? Now what next? So this I2 minimum. Okay, so we need to find the minimum value, na? Yeah, this minimum value. So this I2 will only be minimum when your I bus will have a minimum value into 1 upon 1 plus L2 will be minimum or maximum. Please let me know. Everybody, please let me know. This L2 will we will have to take a minimum or maximum. This L2 value. Guys, please participate. Please participate as much as possible. This L2 value, this we need to take as a minimum or maximum. Definitely, this will be maximum. Okay, then only this I2 will become minimum. And what about L1? This L1 will be minimum. So what is the minimum value of I bus? 20 minus 0.2. Yes, excellent, Saurav. This 20 minus 0.2 will be the minimum of bus. So this will become 19.8 into 1 upon 1 plus L2 maximum. So what is maximum value of L2? The maximum value of L2 is what? 5 plus 0.5. 5 plus 0.5. Okay. So 5 plus 0.5 is 5.5. And the minimum value is what? L1 minimum. See here, L1 minimum is 20 minus 2, 20 minus 2, which is 18. All right, so guys, please give me the answer. Please give me the answer. What is the exact value that we are getting? I have a data as 15.15, 15.166 ampere. 15.166 ampere. So the answer they are asking is rounded to the nearest integer. So what is the nearest integer to 15.166? That is 15 ampere, which is given in, let us check in the option, which is given in option C. So option C is the correct answer for this question. All right, am I clear? Any doubt in this? So how many of you have liked this question? The concept? How many of you have liked? No one. Okay, anyway, moving ahead with the next question. I hope this concept is clear to you. Okay? Let us move ahead with the next question. Nice explanation, sir. Thank you, Pragyavat. So here we are having one numerical answer type question. So numerical answer type question means whatever answer in integer you are getting, you are supposed to be feed here, isn't it? And those answer will lie in the range which is given by the gate authorities. So suppose your answer means while once you have solved this question and you are getting the answer as suppose 15.166 like this one, assuming that. So if the gate authorities has given the range like this one, 15 to 16. Okay, so whatever value in between these two ranges you will write, the computer will going to consider it as a correct answer. Okay, anyway, the exact answer is this one. But if you write 15.5 ampere also, the computer will going to consider that as a correct answer. So the answer which you are getting, if it lies within these ranges, those will be considered as a correct answer. Okay, now let us move ahead with this question. Read this question. A capacitor C equal to 1 plus minus 0.1 microfarad. So this 1 is given in microfarad. Okay, please do not think that this is in farad. So these two values are given in the microfarad manner, where capacitor is charged to a voltage of 20 plus minus 1 volt. Errors are in standard deviation. Now this time errors are provided in terms of standard deviation. Okay, the probable error due to charge on the capacitor is plus minus dash into 10 to the power minus 6 coulomb, rounded up to 2 decimal places. Now, what is the difference between the last two questions and in this question? What is the difference? The difference is of this term, standard deviation. The error can be specified in two ways. The first one, in terms of tolerance or limiting error, and in the and we can also specify the error in another way, which is standard deviation or uncertainty. Standard deviation or uncertainty. So depending on the error, we will going to have the formula. So if you have a tolerance formula that we have seen, now we will going to see the standard deviation formula. Am I clear? Any doubt in this? If you have, then please let me know. Moving ahead, this C is what? 1 microfarad plus minus 0.1 microfarad. So this is basically what? C true plus minus. This is error, but this is given in standard deviation. So in standard deviation, error are specified in terms of sigma. So sigma C for capacitor. Am I clear? Now moving ahead with the next thing, which is a voltage across the capacitor, which is 20 volt plus minus 1 volt. So this is what? V true plus minus sigma V. Okay, so we need to find the charge on the capacitor with a probable error. Okay, so for that we first require the expression of the charge with related to capacitor and the voltage. I hope all of you are knowing the expression of the charge at the capacitor. How many of you are knowing? If you are knowing, then please type in the comment box. Please let me know what is the expression of the capacitor charge value. What is the expression of the charge at the capacitor? Please let me know. All right. So the charge in the capacitor is given by, which is having the expression Q equal to C times of V. Let me write it as equation 1. Okay. Now this is the charge expression. Now if you want to find the probable error, so this is given by probable error in the charge. This is given by, now see the expression, plus minus 0.6, just a second, 0.6745 sigma Q. So sigma Q is the error in the charge in terms of standard deviation. So we require this sigma Q. Let me write it as equation 2. Okay. So this sigma Q is given by, this sigma Q is given by plus minus. Now see here, we have a little difference. In this formula. Differentiate partially charge with respect to all the independent variables. Since we have two independent variables C and V, so first differentiate with respect to V and take it as a whole square into sigma V whole square plus partial derivative of Q with respect to other variable, which is C whole square into sigma C whole square. And after that, take the root. Square root. So this is the formula in terms of standard deviation. Am I clear? Now plus minus root over. Now if you differentiate partially with respect to V, the charge expression, the equation 1, from the equation 1, you will be having here C value whole square into sigma V whole square plus, again with respect to C, you will be getting V whole square into sigma C whole square. Am I clear? Now plus minus root over. What is this C? This is the true value or the standard deviation in the capacitor. This is your true value. So true value in capacitor is what? 1 into 10 to the power minus 6 whole square into sigma V is what? Here we are having sigma V, which is 1 volt. So 1 square plus, what is V true? V true is 20 square into, and sigma C is 0.1 into 10 to the power minus 6. 0.1 into 10 to the power minus 6 whole square. So plus minus. Now once you're going to solve this expression, you will be having the value as 2.236 into 10 to the power minus 6 coulomb. Okay, this is not a capacitor. This is having a unit of charge, which is coulomb. Am I clear? Any doubt in this? Do we have any doubt till here? Okay. Now from 2, we got the value of sigma Q. So this probable error in Q is given by plus minus 0.6745 into, what is sigma Q? 2.236 into 10 to the power minus 6. So on solving this, the resultant value, let me write the resultant value directly. This is 1.51 microcoulomb. 1.51 into 10 to the power minus 6 means micro and coulomb. Am I clear? Any doubt in this? How many of you like this question? Please आग लगा दे एक बार. How many of you have liked this question? So this sort of question you can also expect in the GATE exam, because from the chapter 1 we have only 2 important topics as I have shown you at the beginning of this class, that the standard deviation, limiting error, tolerance, or some of the variables like that. Okay. So if you have understood these two concepts, now definitely whatever question you are supposed to get in the GATE exam, you will be going to have your total or you can say overall marks from this chapter. Am I clear? Any doubt in this? Shall we move ahead with the next question? Shall we move ahead with the next question? Okay, let us move ahead with the next question. Here comes the excellent question. This question has been made by me only. Okay, and this question will test your concept related to the measurement and the control system. The control system gate booster session has already been taken by the Ankur sir. So those who have not yet watched after the session, please go and watch those sessions as well. And those who have already watched, then here I am going to test their concept from the control system. Am I clear? So now read the question. This is basically MCQ type question. The two elements R1 and R2, please do not consider this as a resistor. This is an element. R1 and R2 are connected as shown in the figure. Calculate the uncertainty. Again, we are having the word uncertainty in the error signal E here. Round off to 2 decimal places, where R1 equal to 100 plus minus 1% unit and R2 equal to 200 plus minus 1% unit. Done. So this is a block diagram which is given to you. This is a block diagram which is given to you, and you need to find the error with respect to the variables that we have. Okay. Give a try. Give a try. Let me give you a 2 minutes for this. Give a try, guys. Okay, let me give you a hint. First, find the transfer function E by R. Find the transfer function E by R, and the rest will be the concept that we have already discussed. $25 remaining, guys. Please fast. I know this require a little bit concept, but anyway, the concept we have already discussed. So do it fast. 9, 8. Do it fast. All right, so time's up. Time's up. Now, let me solve this question. Okay, so what we have, we need to find the error which is in terms of uncertainty. So, as I told you, this uncertainty means what? Standard deviation. Okay. Now, looking into the block diagram, we have a positive feedback system. See, this is a positive feedback. We have a positive feedback system, and we have a R1, R2 value like this. So, if you solve this one in terms of absolute, whatever thing we need to find First, you need to convert in terms of their absolute value. So 100 plus minus, what is 1% of 100? Again 1. Okay, and from here 200 plus minus 2. So this is what? This is R1 true plus minus del R1, and this is R2 true plus minus del R2. Okay, this value we have. This value we have. Alright, now let us find the transfer function E by R. So E by R. So this is equal to what? What is the path gain or the forward path gain? What is the forward path gain when you travel from R to E? The value will be 1 only, na? The value will be 1. So this value is 1. Now 1 minus sum of individual loop. What is individual loop here? This is a loop. So R1 into 1 upon R2. So the gain of the loop. So R1 upon R2. So R1 into 1 upon R2. So only one individual loop we are having. Alright, so this will become 1 upon, let me write directly, R2 minus R2 upon R2 minus R1. So this will be your transfer function. So why I have not considered the C value or the C variable? Why I have not considered? Because this C is what? This C is the output, and we don't have the error in terms of their C value. So even if you take, you can get the answer, but you cannot able to find the transfer function, because there is one restriction for finding the transfer function. What is that? The restriction is that for the transfer function, all the other input has to be 0. So even if you take this value, at last you will have to consider this as a 0. So this is the reason why I have not taken this C variable. Okay, anyway, moving ahead, this E will be equal to what now? R2 upon R2 minus R1 times R. So let me inbox this. Done? Alright, now we need to find the error in the standard deviation in terms of their error. So how we will going to find? Let us say the error is given by sigma E. So this is equal to what? Plus minus. This is a standard deviation question, na? So root over. Now differentiate E with respect to all the variables. So this will become partial derivative of E with respect to input signal R whole square into sigma R whole square, plus partial derivative of E with respect to R1 whole square into sigma R1 whole square, plus partial derivative of E with respect to R2 whole square into sigma R2 whole square. Alright, now let us differentiate with respect to R, but that is not at all required. Why? Because if you see the error, in the input, these are not given in the question. The error for the R is not given in the question. So what we need to do? This R is basically what? This input is what? R2 plus minus del R. Okay, R2 is what? The actual value. The actual value is what? Unit step. So this is 1 plus minus. Whether the error for the response, or sorry, not for the response, for the input is given to us. No, this is not given to us. So what we will do? We will assume it to 0. We will assume it as a 0. So the reason being, sorry, not sigma R, not del R, this is sigma R, because whatever value we have in terms of standard deviation, or you can say uncertainty. So this sigma r is 0. So this is the reason why even if you differentiate, ultimately sigma r, when you put 0, this will become 0 overall expression. So there is no need to differentiate with respect to r. Now differentiate with respect to r1, sigma e, e with respect to r1. So first differentiate this one. What we will going to get? Okay, so this r1, see here, this r and r2 will be constant. This r and r2 will be constant. Now differentiate with r1. So this will become minus 1 upon r2 minus r1 whole square, and again differentiate this part. So this will become minus 1. I hope this is clear. Okay, and the end result will be what? R into r2 whole divided by r2 minus r1 whole square. Done. So let us find this value. What is r? R is 1. What is r2? R2 is 200. Done. R2 minus R1. R2 is 200 and 100. So this will be 100 square. Am I clear? Any doubt in this? Okay, done. I hope this is clear to you. Please guys, please respond fast. So the final value is 1 by 50. 200 by 10,000. 200 by 10,000 is what? 1 by 50. Now differentiate again with respect to R2. With respect to R2. So sigma E with respect to R2. So this time what? R and R1 will become constant. So let us differentiate. Here R will be constant and R1 will be constant. So R will be outside. Partially differentiate with respect to R2. So here R2 upon R2 minus R1. Okay. So differentiate it fast. R. So this is U by V form. This is U by V form. So this will become R2 minus R1. In the denominator, we have a whole square. Alright. So left the denominator part and differentiate numerator with respect to R2. So this will become 1 minus. Now left the numerator and differentiate with respect to, differentiate denominator with respect to R2. So this will become 1. Am I clear? Any doubt in this? Done. What after this? The end expression will be R2 minus R1 minus R2. So this will become minus R1 upon R2 minus R1 whole square. Okay. So this R value is 1 into minus R1 means minus 100 whole divided by, this is R2. 200 minus 100 is 100 whole square. So this will become minus 1 by 100. Let me check. Great. Excellent. Am I clear everyone? Any doubt in this? Am I clear? So we have all values. Now substitute this value, those two values, 1 by 100 and minus 1 by 100 in this expression. Okay. As I told you, this value is what? This value is 0. So sigma E, this is equal to plus minus root over 1 by 50 whole square into sigma R1 is what? 1 whole square plus this value is minus 1 by 100 whole square, and error in sigma R2 is what? 2 square. See the expression? Okay. Alright. So on solving this, the sigma E value you will going to get as a plus minus 0.03. Sorry, not in ohm, in units. So the error in terms of standard deviation, the value is 0.03 unit. So the correct option for this question is option C. Done? Clear? Any doubt in this? Please let me know. Do we have any doubt in this, guys? Do we have any doubt in this? Then please let me know. And if you have not got the concept, then also in that case, please let me know. This sort of concept is very, very important for the GATE exam. All right. So with this, we have completed the chapter 1 with a good number of concepts and a good number of questions. Okay. So how many of you have liked this question? How many of you have liked this question? Okay. Shall we move ahead with the next chapter? Shall we move ahead with the next chapter? Okay. So this is the chapter 2, which is measurement of voltage and current. So basically this is what? This is voltmeter and ammeter chapter. Okay. So in that, the important topic is what? PMMC instrument, extension of the range in voltmeter and ammeter in PMMC, and moving iron instrument. So this, if you have covered these these 3 topics, then my friend, you are on a safer side. All right. Now moving ahead with the question. This is a question that we have, and this is a MCQ type of question. Okay, this is an MCQ type of question. So guys, please read the question and let me give you the time for this. You have a 2 minute for this question. If you want some more minute, then please let me know. I will extend the time. Okay. Do it fast, guys. This is a question which can cover lot of concept. Okay, this question will cover a lot of concept related to mathematics, related to measurement, integration, like that thing. Okay, so try to solve this question and give me the correct answer for this one. $20 remaining. Fast, guys. Great, great. Do it fast. 10 seconds. Time's up. Time's up. Now see here. A law of deflection of moving type voltmeter is given by I equal to 4 theta to the power n ampere, where theta is deflection in radian and k and n are the positive constant. The self-inductance of the coil when the meter current is 0 is 20 milliampere. So this line is very, very important. When meter current is 0 is 20 milliampere. With n equal to 0.75, the deflection in degree that corresponds to a self-inductance of 100 millihenry is considered spring constant as 0.16 Newton meter per radian. So basically this question is related to the moving iron instrument, and in that what the examiner is asking is, we need to find the deflection value in degree when your inductor reached this value, which is 100 millihenry. So how are we going to approach this? How are we going to approach this? So for that, what we require, we require the deflection formula in the from the moving iron instrument. So the deflection formula from the moving iron instrument is given by theta, which is equal to 1 by 2 into I square by Kc into del L by del theta. Sorry, del L by del theta. Am I clear? So this is the expression for the moving iron instrument for the deflection. Okay. Now I want this this deflection value na. So what we need to do, or what we can do, we can take all the variables. We can take all the variables to the left hand side. Only we are going to left the del L variable to the right hand side. Okay. So let us take all the thing to the left hand side except this del L value. So this will become 2 Kc I square, 2 Kc I square theta d theta del L. Done. Now integrate the the left hand side we need to differentiate, the left hand side we need to integrate with respect to angle or deflection, and at the right hand side we need to integrate with respect to variable which is inductance. Now see here, when the current is 0, in the question it is mentioned na, when the meter current is 0, the inductance is 20 millihenry. So if the meter current is 0, what will be the deflection in terms of degree? If the meter current is 0, then what will be the deflection in terms of degree? Then definitely the deflection will be 0 degree, isn't it? If there is no current in the meter, then it will show 0 deflection. So initially this theta initial will be what? 0 degree for initial inductor value as 20 millihenry. Am I clear? Now we need to find the deflection theta. Let us say theta for L as 100 millihenry. Done. So let us integrate theta initial, theta final, 2 Kc upon I square theta d theta, and here L initial, L final dl. Am I clear? Now here 2 Kc by I square. Achha, one more thing, I think the expression of theta I is given in terms of angle na, or sorry, not angle, in terms of deflection. Okay, all right. So substitute this two also. Theta I, theta f 2 Kc upon I is 4 theta to the power n whole square into theta d theta. This is equal to Li Lf del L. Am I clear? Now what next? Simplify this expression, theta initial, theta final. So 2 Kc will be constant and this 4 square, which is 16, will be constant. So 2 Kc by 16 into theta upon theta to the power n. This value, this part will be what? Theta to the power 2n, and when it goes to numerator it will become theta 1 minus 2n. Any doubt in this? Please let me know. If you have any doubt in this, then please let me know. This 4 theta to the power n whole square will be what? 4 squared theta to the power n, and if you take this into the numerator it will become minus 2n. Okay, and this side we will be having Li Lf del L. Now substitute the value Kc and n. So Kc value is what? 0.16. So theta initial, theta f 2 into 0.16 whole divided by 16 into theta n value is 0.75. So 2 into 0.75. Okay, one thing we can do here. First we will going to integrate, and after that we will substitute the n value. Am I clear? So 1 minus 2n d theta, here Li Lf del L. So this 2 into 0.16 whole divided by 16. Integrate, it will become theta. X to the power n integration is what? X to the power n integration is what? X to the power n plus 1 upon n plus 1. So here it will become 1 minus 2n plus 1 upon 1 minus 2n plus 1. And limit is theta initial, theta final. And this will be equal to, integrate here, we will be having L, limit is Li, Lf. Done any doubt in this? Then please let me know. So here 2 into 0.16 upon 16 into. So theta 2 minus 2n. Theta 2 minus 2n. Here 2 minus 2n. Theta initial, theta final. And this is equal to Lf minus Li. Done. So what we can do, we can substitute the value. Can we substitute? Okay. So 2 into 0.16 upon 16. Now look at here. I can take 2 common from the denominator. So it will become 2 into theta. Here 2, 1 minus 0.5. Isn't it? Sorry. 1 minus not 0.5. 1 minus n upon 1 minus n. Here theta I, theta f, Lf minus Li. Now substitute the value. 2 will be cancelled out. So here 1 by 100 into n will be 0.75 na. This n is given as 0.75. So this will become theta 2 into 1 minus 0.75. This value is what? 1 minus n. So 1 minus n is 0.75. So this will become 0.25. 2 into 0.25 is what? 0.5. And here 0.25. Theta initial, theta final. Lf minus Li. Okay. Let me rub this. Now what next? What next, everybody? Can we have the answer here? Please let me know. Can we have the answer? Okay. So substitute the limit here. 1 upon 100 into 0.25 into theta final power 0.5 minus theta initial power 0.5. This is equal to Lf minus Li. Done. Any doubt in this? Till here, any doubt in this? Now next. This value is what? 25 by 100. So it will become, what this value become? Please let me know. It will become 1 upon 25. Now see here. Your final value will be what? Theta na? This theta will give the deflection, this theta will give the inductance value as 100 millihenry. Okay, so this is what? This is basically my theta final. Okay, so theta final I have taken as a theta only. So power 0.5, and what is theta initial? Inductor current is 0, then theta will be 0. So 0 to the power 0.5. And what is Lf? Lf is, I have taken, it is given in the question as 100 millihenry. And the initial for this deflection, for theta I, this is given as 20 millihenry. Okay. Mind you, this is not a theta, this is 0. So 1 upon 25 into theta to the power 0.5, this is equal to 80 millihenry, 80 into 10 to the power minus 3. So let me solve this value, or if you have solved, then please let me know what is the value here. Theta to the power 5. This will be 25 into 80 into 10 to the power minus 3. So here if you take the 4 as a common, so 40 into 25 is what? 30. Or you can take, so this is 2000, 10 to the power minus 3 here, it will become 2. It will become 2. Any doubt in this? 25 into 80 into 10 to the power minus 3. So 25 into 4 is 100. 100. Here 2 will be left. Okay. So we will be getting the theta to the power 0.5 as a 2. What next? Theta to the power 0.5. This is equal to 2. So what is 0.5? This is 1 by 2. Okay, I want theta. So for that, what we can do? We can square both sides. We can square both sides. So this will become theta 1 by 2. On squaring both sides, we will be having 2 square here. So here theta, which is equal to 4. But in the question, the answer they are asking is in terms of degree. And this 4 is what? This is given in the radian. This is in the radian. Okay, so how we can convert the radian into degree? Radian into degree. Now look at here, pi radian is equal to 180 degree. Pi radian is equal to 180 degree. So 1 radian will be what? 180 degree upon pi. So where pi is 22 by 7. Okay, so in this way you can convert your pi value or a radian value in terms of degree. Am I clear? Now this theta, which is equal to 4 into 1 radian. 1 radian means 180 degree upon pi, which is 22 by 7. So on solving this, you will get the answer as 229.18. 229.18 degree. So the correct answer for this question is what? Option B. Okay, my dear friend, any doubt in this? How is the question? How was the question here? Easy, pretty much easy, difficult, mediocre? What is the level of the question here? What level you are finding for this? It will be below average, average, or a difficult one? Okay, great. So moving ahead with the next question in this league is this one. Okay. Now this question will test your a subject related to the analog, related to the power electronic and network. So basically this question tests your 4 subjects: analog, network, power electronic and measurement. Okay, now read the question and I will give you 1 minute of time for this. Okay. And this is basically a multiple select question, MSQ type of question. Okay, my dear friend. Give a try. First, read the question. The question is, in the given circuit, ideal voltmeter are placed, one across capacitor here and another across the diode. Then which of the following reading are correct? So we need to find which of the following option are correct. Okay. Okay. Now see here, the diode, whatever voltmeter connected across the diode is MI. So MI is what? Mission impossible. So this question is basically impossible for you to solve, isn't it? Is it like so? No. This MI is what? Moving iron instrument. Okay. This is MI is what? Moving iron instrument. And what is PMMC? This is permanent magnet moving coil. So before heading towards the solution, you first need to know one thing, that which meter will read what kind of thing. So the MI type of meter, let me write here, the MI type of instrument reads RMS value, okay, or root mean square value, whereas your PMMC meter will read what? Average value. If you know this thing now, the answer will be at your fingertip. Okay. Done? Any doubt in this? Till now, do you have any doubt? So let me directly jump to the solution part, hoping that you have tried. Okay. Now look at here. This is the this is the circuit diagram which is given to us, and it is also given in the question that your voltmeter are ideal one and the diode is also your ideal. Okay. Now, basically, whenever, see, this will be what to say, important thing or important point which you will need to add at your pocket. Which point? Whenever you come across the diode, then my friend, you will have to use the cases. What are those cases? The positive half cycle of supply and the negative half cycle of supply, because your diode will work in two region. I'm talking about the ideal diode. Okay, your ideal diode will work in two region. In the forward bias region, the diode will be short circuited, and in the negative bias region, the diode will be open circuited. So these two cases is possible when the working is in the positive half cycle or in the negative half cycle. All right. Now look at here. I am taking the case for the positive half cycle. Case 1 for positive half cycle of supply. The positive half cycle of supply means omega t will vary from 0 to pi. Okay. So this is what basically, this is sinusoidal input. Now when you do so, your circuit will become like this. This is Vs, and look at here. This is plus for the positive cycle. This will be plus and this will be minus. Okay. So plus will come here and negative will come here, like this. At the starting of the at the starting of the supply voltage. So plus will come here and negative will come here. So whenever you will see this sort of notation, your diode will become the forward biased. So forward bias means your diode will behave as a short circuit. So this will be the short circuit. Now what next? You will be having a capacitor over here, and the value of the capacitor is 1 microfarad, and we have a PMMC. And here we have a moving iron instrument. Okay, let us assume that whatever voltage we are having across capacitor is Vc and across diode Vd. Done. Now by looking into the figure, I can for sure I can write that Vd will be 0 volt. Vd will be 0 volt. Now what about Vc? What about Vc? Sorry. Okay, apply KCL in this loop. Apply KCL in this loop. Why we are not applying from here? Because your voltmeter are ideal. Ideal means the current flowing through the meter will be 0. So there is no need to apply the KVL from the MI type. Okay, am I clear? Any doubt in this? Now moving ahead. If you apply the KVL, your Vc will be equal to Vs. Your Vc will be equal to Vs. Okay. Now next thing, let us find the current value or the expression which is flowing in this circuit. Let us say this is IC. IC current is flowing through the circuit. This IC will be equal to what? IC equal to C voltage across capacitor divided by differentiated with respect to T. Done. So IC will be what? C times of d by dt. What is capacitor value? That is Vs, and Vs is what? Supply voltage. So Vm sin omega t. Vm sin omega t. So Vm sin omega t. Now differentiate with respect to t, it will become Vm omega c, and here cos omega t. So let me take this value Vm omega c as a maximum value for the current. So this will become Im cos omega t. Okay, my dear friend. So this will become Im cos omega t. Now what next? Look at here. Let me draw the diagram. Okay, just a second. Let me draw here itself. So this is supply voltage. Just a second. Okay, so this is Vs against omega t. All right. Now next. The capacitor current, which is IC. Please observe this waveform very carefully. Otherwise, the thing will going to above your head. This waveform is very, very important to solve this diagram, or you can say to solve this question, not a diagram, for solving this question. If you are not able to understand this waveform now, then definitely you cannot able to solve the question. Now look at here. First, I will see that exactly at what instant this current will become 0. So for that, let me take the axis here. Let me take the axis here. Please wait, guys. Please wait. Okay. Let me change the color. So I am drawing the VC also in the same same waveform. Okay. Now look at the expression of the IC. This is the cosine value. This is the cosine value. So this point is what? Basically pi by 2. This will be pi. This is 3 pi by 2. This will be 2 pi. Now since this is a cosine value and the maximum value is Im, so at pi by 2, what this capacitor current will have? Will have a 0 value like this. And this is the maximum current Im. Any doubt in this? Any doubt in this? So this is the capacitor waveform. Now what exactly after pi by 2? We are talking about the region. We are talking about the region from 0 to pi for the omega t. So as of now, we are cover only 0 to pi by 2. What about pi by 2 to pi? What is the value of capacitor current, or you can say the current which is flowing here like this, what will be the value of IC just after pi by 2? Now look at here, everybody, look at here. This is very important point. After pi by 2, what means exactly at pi by 2, this capacitor current is what? 0, isn't it? Now just after pi by 2, this current will going to be negative. This current will going to be negative. So what is the meaning of negative current? For the positive, we have considered this direction. Okay, am I clear? Now for the negative means what? This capacitor current will be in the reverse order, like this, in the reverse order. So whenever your capacitor, or you can say whenever your current will flow opposite, like this, opposite to the diode symbol, then your diode will going to be the reversed biased. Whenever the direction of the current is opposite to the symbol of the diode, your diode will behave as a reverse bias, and in the reverse bias condition, your diode will be open circuited. So what is the meaning of this? That exactly pi by 2, whenever your current will going to be negative, this diode will become open circuited, and whenever the diode will become open circuited, means the no current will going to flow through the circuit. No current will flow from the circuit. Am I clear? Should I repeat again? Okay, let me repeat. Exactly at pi by 2, the current will will tend to move in the negative direction. Will tend to move in the negative direction. Whenever the direction is opposite, the current direction is opposite to the diode symbol, your diode will become the reverse bias, and the reverse bias condition, your diode will be open circuited. And when the diode is open circuited, this means that no current will flow in the circuit. No current will flow in the circuit. So this means that between this region, your current will be 0. Any doubt in this? Any doubt in this? So when the current is 0 here, this means that the capacitor, let me use different color, the black one. The capacitor which is earlier Vs, the capacitor which is earlier Vs, it will go to Vm value. This is Vm value, and after that, once this will be open, so capacitor will not going to discharge, because for discharge we require some element. And once this is open, so the capacitor will not going to be discharged because your current is 0. This means that this voltage at pi by 2 will be clamped like this till pi. So the capacitor value will be clamped till pi like this. Done? Do we have any doubt? Then please let me know. All right. Now, exactly at pi by 2, since we know that this is reverse bias, let us find the expression for that. Let me add one more page. Okay. So once this is open circuited, so the expression or the circuit will be like this one. This is open circuited, plus minus Vd, diode voltage. We have a supply voltage Vs here, and we have a capacitor. And exactly at this point, your capacitor value is clamped or fixed to plus minus Vn. Am I clear? Now, let us apply the KVL in this loop to find the Vd expression. Apply minus Vs plus Vd plus Vm, this is equal to 0. So your Vd, this will now become Vs minus Vm. What is Vs? Vs is Vm sine omega t minus Vm. So Vd now become Vm sine omega t minus 1. So this is the expression for the diode voltage. Am I clear? Any doubt in this? So if you want to draw this diagram or the waveform, not a diagram, you can say diagram. This is a Vd against omega t. Just a second. Omega t, let me take this as pi by 2, this as pi, this is 3 pi by 2, this is 2 pi. Okay, so we are talking about this 0 to pi region. So at 0 to pi, this 0 to pi, the diode is open. The diode is short circuited. This means that Vd is 0. Okay, and from pi by 2 to pi, we have this value na. So at pi by 2, this value is 1. 1 minus 1, 0. At pi, this value will be 0 and minus 1. 0 minus 1 is minus Vm. So let me take this as minus Vm. This color is visible or not? Okay, let me use the black color. Vd will be 0 here, and in this region it will be like this, and this is minus Vm. This is minus Vm. I hope this is visible now. Done. So we as of now we have talked about the 0 to pi region. Now what about negative half cycle? Now let us talk about the negative half cycle. Case 2. So let me write here directly omega t from pi to 2 pi. So at pi to 2 pi, again, what will happen here? Minus will come here and plus will come here, because the supply will going to be reverted. Okay. So minus will come here and plus will come here. So this minus will appear here and this plus will appear here. So in the negative half cycle, this diode will again remains open circuited, because this is again reverse bias. So your equivalent circuit, you can say, will be this one. So we have a capacitor plus minus Vc, and we have a voltmeter here which measure PMMC. This is V2 na, and we have a moving iron here, V1 Mi, and plus minus Vt. Done. So this is the circuit diagram for the negative half cycle. So this circuit diagram is exactly the same as that of the previous one, as that of the previous one, like this. Here we have a V2 PMMC, and here we have V1. Okay, so this is basically V1. And what about capacitor value? This capacitor value is, this is V2. All right, am I clear? Any doubt in this, everyone? Any doubt in this? Done? Okay, now if you look here, this diode is reverse bias. This diode is reverse bias. This means that for whole period, this diode will be reverse bias. Then the capacitor value Vc will again be equal to Vm. And what about Vd? Vd will have the same expression, Vm sin omega t minus 1, because this circuit diagram is same as that of the previous one. Done? Any doubt in this? All right. So exactly what is happening here, from pi to 2 pi, this capacitor voltage, this Vc, this capacitor voltage, let me change the color, will be fixed to Vm here till 2 pi. Okay. And what about capacitor current? Capacitor current is still 0. Capacitor current is still 0 till 2 pi. Done. And what about this value, the Vd value? At pi, this is minus Vm. At pi by 2, this will become what? Minus 2 Vm. Isn't it? At pi by 2, this will become minus 2 Vm. Okay. Now after this, this value will going to be increased in the positive direction. So it will tend to decrease. Just a second. This value will tend to decrease like this. Am I clear? Is this waveform is clear to you? So this is the waveform of the diode for the period 0 to 2 pi, 0 to 2 pi. Okay, now what about the period, or what about the period when your this 2 pi has been extended? Okay, what about what after 2 pi? What after 2 pi? Now see, after 2 pi, see this value. After 2 pi, this will go to positive, means from 0 to 1. It will go from 0 to 1. So for omega t, okay, let me write here. Okay, so I am talking about the case third, omega t from 2 pi to 3 pi. Okay, so this expression is again valid for this region Vd Vm sine omega t minus 1. So this sine omega t is what? It will vary from 0 to 1. It will vary from 0 to 1. So this Vd, just a second, this Vd for this value, for omega t from 2 pi to 2 pi to 3 pi, this Vd will be lie between the region omega 0 to minus Vm. Am I clear? If you put 2 pi, it will be minus Vm. If you put this is 3 pi by 2, sorry, this is 3 pi by 2, and if you put 3 pi by 2, it will become 1. So this will give you 0. So this means that your Vd will be negative. Your Vd will be negative for this period. Now what it implies? It implies that let me change the color. It implies that since Vd is negative, diode will be reverse bias. Diode will be reversed bias. Very important statement or concept. Reverse bias means your diode will be open circuit. Your diode will be open circuit. So just after 3 pi by 2, your waveform will going to be repeated as that of the previous one. So for that particular reason, let me draw the waveform, complete waveform for you. Just a second, let me use the shape. Please wait, student, please wait. Meanwhile, let me draw the axis. Just a second, just a second. Okay. So let me take this as a pi by 2. This as a pi by 2. This is pi. This is 3 pi by 2. This is 2 pi. This will be your 5 pi by 2. This is 3 pi, I guess, है ना, and so on so forth. ये आपका ऐसे ही means this point that I have taken at the x-axis. Now let us draw the thing here. Let us draw the thing here. So first I will draw the VD. Sorry, not VD. That VC. That VC. So exactly from 0 to pi by 2. This is 0. From 0 to pi by 2, it will go like this, and this will be your maximum value Vm. And just after this, this value will be fixed. Am I clear? Now what about IC value? Let me draw the IC value here. This is what? Plus Im, and this is cos, na? Sorry. Like this. And after that, this will be 0 for all the operations. This will be 0 for all the operations. Now let me talk about okay, just a second. Let me talk about the VD expression. Okay, from 0 to pi by 2, the diode is forward bias, so it will be 0, isn't it? That will be 0. Everybody, please let me know. Do we have any doubt? I'm not getting any response from your side. Please let me know. Are you getting this? And after that, this will be minus Vm at here, and at 3 pi by 2, this will be minus 2 Vm. And after that, this has decreased. Sorry. Like this. And it will become 0, and again it will going to start like this. Done, everyone? Done? So this will be the waveform for the VC and VD. Now how to find the reading from the MI and your and the average value? So since we know that your MI meter will read the RMS value, so this moving iron is connected across the diode, है ना? Across the diode, and the diode will have the value V1. The diode will have a value V1. So this V1 will be equal to what? What is the RMS value of this capacitor, or you can say the DC value? What is the RMS value of the DC value? The RMS value of the DC value is what? RMS, that DC value only, isn't it? So the RMS value of DC value, the RMS of the DC value will be Vm. Okay, so this Vm is what? √2 times of RMS value. So this value, which is given as 230 volt, this 230 volt is what? Basically this is RMS value. So your Vm or the capacitor or Mi value will be root 2 into 230 volt. So when you solve this, you will get the answer as 325 volt. Okay, look at here, this is V2, sorry, the capacitor voltage is what? Okay, the capacitor voltage is V2. Okay, and it read average value. Okay, so it read average value. Am I clear? It read average value. So extremely sorry for that. This V is what? This is PMMC, and this is average value. This is average value, and this is V1, and this is V1. Sorry, this is V2. Look at here, this is V2. So the anyway, the average value or the RMS value, average or RMS value for the DC signal will be that value only. So which is Vm. So on solving this, root 2 into 230, this will become 325. So let us find this Vd value. This Vd is what? This is connected across the moving iron instrument, and we know that moving iron will read RMS value, and this Vrms is what? Basically V1. Look at the diagram. The reading will be V1. So how to find the RMS value? So V1 value will be, take the waveform for one period. Take the waveform for the one period. So let me take from pi by 2 to 5 pi by 2. Okay, please make it clear that we need not have to take this 0 to pi by 2 value, because this is a transient period. And we can only find the RMS and the average value for the steady state, or once the stable state has been achieved. So for the transient period, there is no concept for the RMS and the maximum value. The RMS and maximum value can only be found for the stable period, or you can say once the steady state has been achieved. So the steady state has been achieved from pi by 2 to 5 pi by 2, and the waveform will going to repeat itself. So under this case, V1, this is equal to 1 upon 2 pi integration from pi by 2 to 5 pi by 2 Vd whole square d omega t. What is Vd here? From pi by 2 to 5 pi by 2. What is Vd expression? Vd is Vm sine omega t minus 1 whole square and d omega t. Okay, and one more thing, we need to put the root value. Then also, then only it will become the RMS value. Am I clear? So put root over like this. All right, just a second. Just a second, give me some time. Okay. Now, when you solve this expression, you will going to get the value as Vm upon root 2 pi. Vm upon root 2 pi means this Vm whole square, when you bring out from the root, it will become Vm, and this 2 pi is what? When this will come under root, it will become Vm Vm upon root 2 pi. Now, the things which we are left here, when you solve this, you will get the expression or the value as root over 3 pi. So whatever value after taking out omega m and 2 pi, the value will become root over 3 pi. Okay, and the value, let me write it directly, 398.37. 398.37 volt. 398.37 volt. Okay, so I have left the calculation part for you. So please check it once and definitely you are going to get this answer. Now let us go back to the option and check in which option we are getting. So 398 in this option and 325, no? 325.22. So the correct answer for this question or option is option B and C. Alright, so any doubt in this? Do we have any doubt in this? So I hope you have got the concept. Here the concept which we need to learn or remember is moving iron read RMS value and PMMC read average value. Rest is your analog or you can say the network part. Alright, now let us move ahead with the next question, which is this one. A moving coil instrument having a resistance of 5 ohm gives a full scale deflection when the current is 50 milliampere. What should be the value of the series resistance ohm so that it can be used as a voltmeter for measuring potential difference up to 250 volt, rounded to 2 decimal places. So this is basically numerical answer type question, and this is one of the important question when you think about the GATE exam. Definitely this sort of question you will get in the GATE exam in the year 2023. And if you are able to solve this question, then my dear friend, the 2 marks or 1 marks, whatever marks allotted to this question, you will be having at your bucket. Am I clear? Any doubt in this? So please solve this question. All right. Now look at the important thing. The moving iron coil instrument having a resistance. So this resistance is what basically? This is meter resistance, which is 5 ohm. What next? It will give a full scale deflection when the current IM, this is not a maximum current, this is measured current, which is 50 milliampere. Now what should be the series resistance RAC, which is to be added such that your voltmeter reading range has been extended to 250 volt. Done. Now for this particular question, let me give you a glimpse of the voltmeter from the PMMC. So the PMMC meter is represented like this one. Internal resistance RM, and we have a indicator like this, or you can say galvanometer. So this RM is basically inside the meter. This RM is basically inside the meter. So to give you a clear picture, what I did, I have taken this resistance out from the meter and I have placed here. Any doubt in this? Now, but exactly at this time, the current flowing in the circuit is IM. Done? Any doubt in this? Done? Now, once you do this, the voltage VM, which is to be measured, is what? IM into RM till this point. Just a second. Okay. Till this point. All right. Now give me the value here. IM into RM. IM we have na 50 milliampere and RM is 5. So 50 into 5 is 250 milliampere. So this will become 0.25 volt. Done. So this is the case when the range has not extended. Now let us extend the range by connecting the series resistor. Okay, so this is RAC. Now definitely the question will come to your mind that, sir, how you know that the resistor which we need to add will be connected in the series? Why not the resistor can be connected in the parallel? The reason is, when you connect the resistor in the parallel, the current range will extend, and if you connect the resistor in series, then the voltage will going to be extended. Am I clear? Any doubt in this? So please keep this thing in your mind. Whenever you connect the resistor in series, the voltage will going to be extend, and if you connect the resistor in parallel, the current will going to be extend. Now this RAC we need to calculate. All right. Now once you added this resistor, your voltage range has been extended from 0.25 volt to 250 volt. Like this. Am I clear, everyone? Am I clear? So if this is 0.25, then this value will be what? 250 minus 0.25. 250 minus 0.25. Done? Am I clear? Now what about the current? Means before extending the range and after extending the range, whether the current will change or the current will remains the same. The current will remains the same. The reason is this Im is the maximum current which is flowing through this this voltmeter. Am I clear? Any doubt in this? Let me take the example here. Suppose this Im is this Im is given as 50 milliampere. Now let me extend this current by assuming that 51 milliampere as a value. Now this 51 milliampere, this 50 milliampere is what? This is the current which is bearable by this voltmeter, Now if you extend this current now, this meter will going to damage. This meter will going to be damaged. So in any case, we are not in a situation to extend this current. Otherwise, your meter will going to be blast or damaged. So this Im current will going to be fixed as 50 milliampere. Done? Any doubt in this? Any doubt in this? So can I say the 50 milliampere current is also flowing through this RAC? So RAC is what? Basically, this is 250 minus 0.25 whole divided by Im. So 250 minus 0.25 upon, this is 50 milliampere na, into 10 to the power minus 3. So when you solve this, you will get the answer as 4995. Am I clear? So the correct answer for this question is 4995 ohm. So this is the conventional method, or if you want to clear your concept now, then definitely you should first understand the conventional approach. Now let me give you the shortcut method. Method 2, that is shortcut. Okay, so whenever you want to extend the range, then RAC expression is what? This is equal to Rm times extended voltage divided by Vm, means before the extension of the voltmeter, minus 1. This Rm is 5, I guess. Let me check. This Rm is 5. This Rm is 5. This V is given in the question as a 250. This Vm we have calculated na. So this Vm will be 0.25 minus 1. So what is this value? 5 into 25. 25 will be cancelled out. This will become 1000 minus 1. So 5000 minus 5. 5000 minus 5 will be 4995 ohm. The same answer. Am I clear? So either you can go with the conventional approach, which is better to understand, but for the GATE exam, you should use this method 2 formula. Sorry, this method 2, which is formula based. Am I clear? So this is the expression when the range has been extended in case of voltage. What about the current? In the current, we need to add the resistor in shunt. So this RSH will be equal to Rm upon extension of the current upon when the current has been not extended minus 1. Am I clear? So this will be the shunt resistance if you want to extend the current range. Anyway, let us move ahead with the next question. Now let us come to the topic, which is chapter 3, measurement of power. All right, guys. So move ahead with the topic, that is measurement of 3-phase power, which is very, very important in this chapter. Means you can expect a question only from this topic. Okay, means the frequency of the question from this topic is very, very high. All right, let us move ahead with the question directly. This is a MCQ type of question where this question can judge your concept based on the AC circuit which you have studied in the network. Alright, now read the question. A wattmeter reads 4000 watt when its current coil is connected in red phase and pressure coil is connected between red phase and the neutral of a symmetrical 3-phase star connected balanced load of a power factor 0.8 lagging. The phase sequence is RYB. What will be the reading of the wattmeter if the pressure coil alone is connected between the black and yellow phases with all other connection remains unchanged? Okay. So if you see here, we will have to frame two cases. Case 1. Case 1. Case 1 is what? When current coil is connected in R phase and pressure coil is connected between R and neutral. Okay, so your symmetric diagram will be like this. This is current coil. This is Z. Now let me consider the star connected load. So whenever the type of load is not given to you, means whether the load is connected in the delta or star, then we will assume it as a star connection. Okay. Z and Z. Okay, and the power factor is given as 0.8 lag. Okay, so this is R, this one will be Y, and this is B, and this is current coil, and this will be your pressure coil which is connected between R and neutral. So this point is your neutral point. Okay, so this case is basically a measurement of single phase wattmeter, not a single phase. Here you have connected a 1 wattmeter. So basically this is a case where you are measuring a power across only one phase. Am I clear? Now in this particular situation, okay, so in this particular situation, what we have wattmeter reading P. Let me write wattmeter reading as P, which is 400 watt, and the power factor cos phi is given as 0.8. So what is power factor angle? This will be 36.87 degree. Am I clear? Any doubt in this? This is 0.7 lag. All right. Now for the single phase, by looking into this diagram, by the single phase, the wattmeter expression will be P equal to VPH IPH cos phi. So this P is 400, VPH and IPH are unknown, and cos phi is 0.8. Cos phi is 0.8. So once you solve this, VPH IPH will become what? 500 volt ampere. 500 volt ampere. Done. So this information we are getting from the case 1. Now what next? In the second case, the wattmeter pressure coil is connected between black and yellow phases. So let me frame a second case here. Second case. Okay. So in the second case, your current coil connection is unchanged, which is connected in R phase only, and we have a impedance like this. Okay, so this is Y and this is B. But at this time, your pressure coil is connected between Y phase and B. Just a second. this is pressure coil, and this is connected between Y phase and B phase, and this is what? This is wattmeter. Done. So this is the symmetric diagram for the case 2. All right. So we need to calculate what is the reading of this wattmeter. All right. So for that, what we require the expression of this wattmeter. We require the expression of this wattmeter. Now look at here. Your wattmeter reading. Your wattmeter reading will be what? Voltage across pressure coil, current across current coil, through the current coil, and cos of angle between VPC and ICC. All right, guys, please do share the session, like the session, so that we will going to have a good sort of interaction while solving the question. Okay, am I clear? So please like the session, and please tell your friend to join the session, because we have a very grateful session which is going on. Okay, so let us solve the wattmeter reading for the case 2. All right. Now, this is VR, Vy, and this is Vb. So this is the vector diagram of your voltage. Okay, Vrn, this is R to neutral. So Vrn is what? Basically VR. Neutral voltage is taken by default as a 0. So Vrn is basically VR. Okay, you can write Vrn equal to VR. Both are same. Done. And since this is a positive sequence, so after R, Y will come, and after that B will come, and all will have a phase angle as 120 degree. 120 degree, 120 degree, 120 degree. Done. So if you look at the pressure coil, we want pressure coil. So your pressure coil is connected between Y and B. So this VPC is basically what? VPC. This is basically V. Just a second. VYB. Please do not take VBY. Please do not take VBY. Why? Because this VYB is what? Basically VY minus VB. So for the positive sequence among Y and B, Y will come first. So that is why I have taken positive. For the negative phase sequence, B will be positive. Am I clear? So this is VYB. So we have VY here. I want minus VB. So since VB is here, minus VB will lie exactly opposite to this. This will be minus VB, and we'll take the vector sum of these two. Vector sum of these two means like this, and for Vy will be like this. Okay, and connect this one. So this will be VYB. VYB. Now what about current ICC? What about current ICC? This current ICC will lag the voltage. The current ICC will lag the voltage which is here across this branch by an angle 36.86. This we have seen in the case 1. Your current will lag the voltage by an angle 36.86. So lagging means this VRY. So lagging means this will lag. Let me change the color. The current IR will lag the VR by an angle 36.87 degree. Done. Am I clear? Any doubt in this? So what is IR? This IR is basically the current coil current from the R phase. Now, but I want the angle between VPC and ICC. So what is VPC? This we have seen, this is V by B, IR, and cos of angle between V by B and IR. Alright, so we have V by B here and IR here. So how to find this value? So see here everyone, this overall angle will be 180 na, 180. So this angle will be 180 minus 120 will be 60, isn't it? This angle from minus VB to VY, or you can say VR to VY, is 120. So this angle will be, just a second, this angle will be what is happening, just a second, this is 60. Alright, and this VYB will act as the angle bisection, 30 degree, and this will be 30 degree. This VYB will act as angle bisector for the 60 degree. So angle bisector means it will divide the angle in two equal half. Now if you see the angle between IR, let me choose different color. Okay. This IR and VYB. So from, I want this angle. I want this angle. So this angle will be what? This total is 90. 60 plus 30, this total is 90, and you subtract 90 from 36 minus 87. Let me take this as a 5. Let me take this as a 5. Okay. So this will become what? This expression. Let me write here. This W will be what? This will be VPC, ICC, and cos of 90 minus 5. I hope this is visible, na? हाँ. रुपेश कुमार सर फ्रीक्वेंसी मीटर वाला क्वेश्चन नहीं हो पाता है. रुपेश, दिस फ्रीक्वेंसी मीटर, आई होप यू आर not talking about the Vance bridge. This frequency meter is not in the GATE syllabus. So my suggestion is to skip those topics which are not in the GATE syllabus, because anyway you are not going to get the question from those topics. So it is my humble request to skip those topic or question related to those topics which are not in the current syllabus. Am I clear, Rupesh? Thank you for asking the question. Now moving ahead, what is VPC? VPC is the voltage across this one. So this is VYB. VYB is what? Line to line voltage, na? So let us replace VPC by VL, line to line voltage. And what is ICC? This is the current flowing through the line, IL. And cos 90 minus phi is what? Sin phi. So what is VL IL sin phi? Or else if you multiply for a clear observation, Q root 3 times of W. This will become root 3 VL IL sin phi. So what is root 3 VL IL sin phi? So this is basically your reactive power. So by using this sort of connection, we can measure the reactive power. Am I clear? Any doubt in this? So please remember this formula, this one. Okay, and if you multiply with root 3, you will going to get 3-phase reactive power. Okay, so while solving the question, please read the question statement very carefully, whether he or she asking the total three-phase power, or it is asking for the wattmeter reading. Okay, Rupesh sir, sorry sir, digital timer counter का बात कर रहा हूँ. Okay, आप डिजिटल टाइमर काउंटर का बात करें. So I hope I hope those topic has been already covered in the digital subject. So if you have already covered, then definitely there is no mark of the question type of thing. Means basically there should not be any question mark. Am I clear? But anyway, if you skip those questions, it will not going to affect you a lot. All right. Otherwise, if you're going to read particularly at this time now the new topic, whatever thing you have already studied will going to be vanished out. So my humble request is to skip this topic which you are which as of now you are not knowing, or you are about to start the topic. Okay. So please skip those one. All right. Now coming back to the topic. So here this type of configuration will read the reactive power, and if you're going to multiply with √3, you will going to get the total 3-phase power. All right. So this W, this wattmeter will read VL IL sin phi. So this W will be VL IL sin phi. So VL is what? √3 VPH. And IL is what? ICC for the star, IPH for the star connection. And what is sin phi? Can I write it as √1 minus cos square phi? Isn't it? So √3 into VPH, IPH, which this we have got from the case 1, which is 500, into √1 minus cos phi is 0.8. This is given in the question. Okay, so this is √3 into 500 into 0.6. So on solving this, we will have the value as, let me write the value directly, 519.62 volt ampere reactive VAR. Rupesh, are you clear? Is it clear, Rupesh? Okay. So let us see in which option it is given. 519.6 VAR. So if you look at the option, this is the first option is in terms of watt. So watt will have the unit for real power, and definitely this will be wrong because your reading will give you the reactive power. So reactive power is given in option B. So option B will be your right. So in this way they can bluff you. Okay, so always be clear about the concept. Means what connection will give you what reading, whether it is giving the real power or reactive power. All right, so I hope this is clear to you. Let us move ahead with the next question, which is this one. Okay, the power input in a 3-phase 3-wire delta connected balanced load is measured by the 2 wattmeter method. The reading by the 2 wattmeter method, I think this is redundant. Ignore this part. The reading of the wattmeter A is 5000 watt and the wattmeter B is minus 1000 watt. If the voltage of the circuit is 440 volt and 50 hertz, what element should be connected in delta at this source such that both wattmeter will always show positive reading? A great twist. Excellent. Thank you, Ankit. All right, so basically this question belongs to the measurement of the 2 wattmeter in which you should know the concept about the power factor, related to the power factor. All right, now here I can say that by using this reading, the reading which is given here, wattmeter B is minus 1000 watt. So whatever power factor I am supposed to get by using this, see here, whatever power factor I am supposed to get by solving wattmeter A and wattmeter B reading, definitely those power factor will be greater than, power factor angle basically will be greater than 60 degree. The reason is whenever the power factor is greater than angle, whenever the power factor angle is greater than 60 degree, then one wattmeter will read the negative value. Am I clear? So let us move ahead. So your phi is what? Tan inverse √3. First wattmeter reading is PA, second wattmeter reading is PB, whole divided by PA plus PB. Now substitute P and PB value. PA is 5000 and PB is minus 1000. Let me change the color. Okay, so this 5 10 inverse root 3 PA is 5000 minus PB is minus 1000 divided by PA plus PB. So this value 5 will be equal to what? 5 will be equal to what? Let me directly write the data. Value. This is 68.95 degree. And I know from the beginning that whenever your reading is negative, one reading is negative, your power factor angle will be greater than 60 degree. Am I clear? Now, what question says for what value we need to connect at the source such that my reading will become positive. So when the reading will become positive, when the power factor angle is less than or equal to 60 degree. If the power factor angle is 60 degree, then 1 wattmeter will read 0, and if it is less than equal to 60 degree, then the wattmeter angle, or you can say the wattmeter reading will be positive. Okay, so let us move ahead. Okay, so basically here this power factor phi is what? 68.95 degree. So this is basically what? This is the lagging power factor, means whatever formula that we have derived, that we have considered for the lagging power factor. And here, since it is not mentioned about the type of load, whether that is RL or RC, then by default we need to consider the RL type of load. So this is what? This is lagging type of load. Alright, now if you want to reduce this power factor angle such that you will going to get the positive reading, then your equivalent impedance should be what? This is XL, this is XL, then the angle can only be subtracted if you subtract the impedance, when you subtract this impedance. Am I clear? Any doubt in this? Please let me know. Why I am saying this? Why means how I am saying this? See, tan phi, this we know the expression. This is what? Reactive value divided by resistance value, means the impedance of the load, means for this case 68.95. This will be what? This will be the combination of the resistor and inductor. So that tan phi or phi for this case will be those parameter. Now if you want to reduce this angle to 60 degree such that you will going to get the reading as a positive one, then definitely we will have to subtract. So subtraction can only be possible if you add capacitor like this. Am I clear? Got it, sir? Excellent, Vipin. Excellent. All right. So here the two thing will be unknown. What is XPH and RPH? Okay. For that case, let me find the mode first. XPH minus XC I need to calculate. RPH is unknown. Okay. Now this phi should be less than equal to 60 degrees such that my reading will become positive. So this phi is what? Tan inverse XPH minus XC divided by RPH, and this should be less than equal to 60 degree. Now how to find XPH here? Now see, XPH will be what? Just a second, let me go back to the question. This is what? This is a reading of the wattmeter, which is 5000 and minus 1000. So what is the power input, or you can say the real power? Real power, this is what? P, which is the addition of the two value. I hope this you have studied in your measurement of wattmeter. So the real power is given by addition of the two values. So this is 5000 plus PB is minus 1000. So this will become 4000 watt. Okay, so this 4000 is what? This is real value, and this is three-phase power measurement. In the three-phase, the PB is what? Root 3 VL IL cos phi, and this is 4000 watt. This is 4000 watt. Okay. So root 3 VL is 440. This is given in the question. IL is unknown. Cos phi is what? This we have calculated na? Where? 68.95. Cos 68.95. So this is equal to 4000. So once you're going to solve this, you will get the value of IL as 14 point, let me write it directly, 14.612. Okay. But this is what? This is line current and the connection is delta. So let us find the phase current over here. So in the delta connection, phase current is given by IL divided by root 3. So substitute this IL here, you will get the value as, just a second, let me write it directly, 8.436. 8.436 ampere. Done. Any doubt in this? Now, why I have calculated this IPH? This I have calculated so that I can get the impedance value. What is impedance? Suppose you have a load like this. Just a second. Suppose if you have a load like this, ZPH. So voltage across here is VPH and current here is IPH. So what is ZPH here? ZPH will be equal to VPH divided by IPH. What is VPH? VPH is a phase voltage, and in the delta, line and phase both are same. What is phase current? This is 8.436. So this value will be equal to, let me write it directly, ZPH 52.15 ohm. Done? Clear? Now, how I can find the RPH? RPH will be what? ZPH cos phi. ZPH that we have already calculated, and cos phi we know. So this ZPH is 52.15 into cos of 68.95 degree. So this value will be 18.73 ohm. All right. Now what about XPH? XPH will be equal to root over ZPH square minus RPH square. So we have ZPH, we have RPH, so XPH will be 48.67 ohm. So we have XPH, we have RPH. Let us substitute in this expression. All right. So just a second. So tan inverse XPH is what? 48.67 minus XC is unknown, whole divided by RPH. RPH is 18.73. This should be less than equal to 60 degree. All right. So here XC is what? Here XC is what? 1 by omega C. Please do not take the imaginary size, because at the beginning I have already taken the imaginary sign. Okay, and after that substitute XC equal to 1 by omega C. Omega is what? 2 pi f. F is given as a 50 hertz. So once you substitute this XC over here, your C value will be less than, okay, just a second, your C value will be less than equal to 196.147 microfarad. So if you select a capacitor value, if you select the capacitor value which is less than this one, then your wattmeter reading will always be positive. So let us see in which option we are having the capacitor value less than 196. So this one and this one. So the correct option for this question is option B and C. I hope this question is clear to you. All right. Let us move ahead with the next question, which is this one. Again, the very important question. The current coil of a dynamometer type wattmeter is connected to Vs of T equal to 50 sine 314 T volt in series with a 10 ohm resistor. The pressure coil is connected through a rectifier in series with 50 Hz source of 200 volt. The inductance of the pressure coil is negligible. Compute the reading of the wattmeter. So this is the wattmeter in which the current coil is connected across this circuit element and the pressure coil is connected with this circuit element. And again, you have a diode here. So definitely this diode will, what it will do? It will block the negative half cycle. All right, so wattmeter reading from here. Can I say wattmeter reading will be equal to VPC into ICC, this current, into cos of angle between VPC and ICC. Done? Any doubt in this? Or else what we can do? We need to find the reading of the wattmeter. Okay. So the reading of the wattmeter will be what? Average value. The reading of the wattmeter will be what? Average value. So this will be equal to 1 upon 2 pi integration over 2 pi VPC omega t, or you can say T only, ICC T d omega t. Sorry, d omega t. Done? All right. So what is VPC here? VPC value will be this one, the voltage across this pressure coil. Now, if you look here, we have a diode, and this we have discussed in the second question, I guess. Basically, I think in the second question, or no, in the sixth question we have discussed. Okay, in the sixth question where we are finding the capacitor value and the diode value, that moving iron PMMC. In that we have discussed where in the negative half cycle this diode will be acting as a reverse bias and it will open circuited. All right. So during the positive half cycle, this will be short circuit. Sorry, this will be short circuit and this will be replaced. Not exactly the short circuit, because at this particular instant the diode will have a resistance 10 ohm. Earlier this 10 ohm are not given to us. Was not given to us. That is the reason why we have considered a short circuit. But this time they have given 10 ohm. So at forward bias region, what we need to do, or at the positive half cycle, what we need to do? We need to short circuit this diode and replace that with the 10 ohm resistor. So for that, case 1. Case 1, when omega t from 0 to pi. So diode is on and resistors of the diode, let us say RD, which is given as 10 ohm, and RPC is given as 5 kilo ohm. So VPC, apply the voltage division rule. So VPC, excellent question. Thank you, Vipin. This VPC will be equal to what? This voltage. So this is what? This is RMS value. Okay, this is RMS value. So let me take that as Vm, or let me write directly √2 into 200 into, so this is what? This is total value, maximum value, you can say, into sine omega t. What is omega here? 2 pi f, which is 315. F is 50 hertz. F is 50 hertz. So omega will become 314. So I have replaced 314 with the omega. So this is Vs value, you can say. Vs value, which is √2 into 200 sine omega t. So this is the Vs value into 5000 divided by 5000 plus 10, because during positive half cycle this is on. isn't it? So when you solve this, you will have the value as 282.278 sine omega t. All right, now what about the current, ICC current here? ICC during the positive half cycle, this is also having the frequency 50 Hz. It is given in the question, I guess. 314 means what? Frequency is 50 Hz. So this ICC will be Vs of t whole divided by 10 ohm. So Vs of t is given as 50 sine 314. So 50 divided by 10 is 5 sine omega t. 5 sine omega t. Done. Now let us come to the case second, when omega t is varying from 0 to, sorry, not 0 to, from pi to 2 pi. Done. Now from pi to 2 pi, this diode will be open circuit. Open circuit means no current will flow. So in that particular case, your VPC will be 0, because whatever voltage we have at the supply will appear across this diode. So VPC voltage will be 0. Now what about the current? So since we don't have any diode connected across this CC, your ICC will be the same, sine 340 t. All right. Now if you draw the waveform, VPC of t okay, and ICC of t. Okay, let me write here omega t. Okay, so during the positive cycle, we have a value like this, sinusoidal, and maximum value is 282.278. And after pi, this is pi value. After pi, it will be 0 to till 2 pi. Isn't it? And what about the current? The current is 5 sine 314 t. Okay, so this is 5 as a maximum value, and in the negative half cycle, it will be like this. This is -5. Done. So if you draw the power circuit diagram, sorry, if you draw the waveform of power, of omega t, so power is what? Multiplication of voltage and current. So for this part, we will be having the value of the power, but at this part, voltage is 0. So we are having only one cycle, like this. And this P is what? VPC of t into ICC of t. Am I clear? Since this is 0, so for pi to 2 pi, your average power will be 0 only. Done. So P average will be what? 1 upon 2 pi integration 0 to pi, and from pi to 2 pi it will be 0, na? So what is VPC? VPC is 282.278 sine omega t into current is 5 sine omega t into sine and sine will become sine square omega t d omega t. Done. Any doubt in this? Do we have any doubt? So from here sine, and from here sine, it will become sine square. Now after solving this integration, let me directly write the result. You will going to have the answer as 352.85 watt. So the integration and differentiation, whatever thing we have here, I have left to you. Okay. So the integration will be simple. Just convert this sine square omega t in terms of cos, and rest will be the integration and the substitution of the limit. Am I clear? Do we have any doubt? Please let me know. We don't have a doubt, na? All right. Is it clear, everyone? Guys, please like the session and please share the session with your friend. Okay. This is for the motivation for me and as well as for you. Because if you have a healthy competition, then definitely you will going to know that at what point we means exactly at what sort of level we are preparing. All right. All right. So shall we move ahead? All right. Let us move to the next question, which is from the bridges. So these are the important topics. If you have already covered, then my friend, you are on a safer side. Okay. So this all topics have been covered by you. Then only you are on a safer side. Means whatever question you are supposed to get in the GATE exam, you can able to solve. All right. Let us move ahead with the question that we have. An unbalanced bridge, AC bridge, is shown in the figure. What maximum voltage can appear across the detector for X varying between this range, where colon double colon is implies belongs to. So this is the value, this is the option given to us, and this is your AC bridge. Fabulous question. Thank you, Vipin. Thank you. So let us find here. We need to find the maximum value across this detector. Now, since no information about the impedance is given for the detector, so we will assume the impedance of the detector as infinity ohm, which is the ideal value of the resistance, or you can say the impedance value. Am I clear? Any doubt in this? Now, let me take the value of VD as plus minus, that the detector voltage, the voltage across detector is VD, which is plus minus VD. Let me write here plus minus V1 and here plus minus V2, and current here I1 and current here I2. Okay, now let me change the color first. Apply the KVL in this loop. Apply the KVL in this loop. All right. Please be clear that since the detector has an impedance of infinite, so no current will flow here. And this current 0 ampere is not by the bridge balance condition, because in the question it is mentioned, it is already mentioned the bridge is unbalanced. So that this current is 0 because of the infinite impedance. All right. Now apply the KVL in that loop. It will become V1 plus VD minus V2 equal to 0. So while you moving in the loop direction, the plus will come first. So that is the reason I have written plus V1 plus VD, and here for the VT negative will come first. So this is the reason I have taken minus V2. So VD will be equal to V2 minus V1. All right. So how to find V2? V2 will be equal to total voltage across this series branch, because this current, this I2 current will also flow here, because this is because we don't have any current here, and the I1, the same current will come here, that I1 current. All right. So if you see, this voltage, supply voltage will appear across this element. So let me directly write the expression. This V2 will be equal to total voltage into opposite value of the capacitor, which is C, whole divided by sum, C plus C1 plus X. This has been already covered in the network subject, and if you have not watched this, those session, please do watch those session as well. Okay. Into minus into E. V1 is this voltage. So take the opposite capacitor, C1 minus X, divided by sum of these two capacitors. So C plus C1 minus X. So this will become E times, let me take E common from both. Here 1 upon 1 plus 1, 2 plus X, minus here 1 minus X upon 2 minus X. Done. Now let us simplify this expression. Here Vd will be equal to E times of 2 minus X upon 2 plus X. So here 2 minus X will come, minus 1 minus X, here 2 plus X. Check once. 1 minus X, 2 plus X, and here 2 minus X. Okay. So let us simplify this. E times of, this is A plus B, A minus B. So 4 minus X square. And here 2 minus X minus 2 plus X minus 2X minus X square. Done. E times of 4 minus X square. So here 2 minus X minus 2 plus X minus 2X minus X. It will become plus X and minus minus plus X square. Done. So 2 will be cancelled. Just a second. This 2 and this 2 will be cancelled out. Minus X plus X will be cancelled out. So here we are left with Vd. This is equal to E times of X square upon 4 minus X square. Now we have an expression of Vd. Now how to find the maximum value? By differentiating this expression against the variable X, against the independent variable X. So if you differentiate this, what we will get? We will get the value as 4 minus X square whole square. Here 4 minus X square, differentiate numerator 2X minus left numerator, then differentiate the denominator 0 minus 2X. Okay, so once you will going to solve this one, you will get the value as 8X upon 4 minus X square whole square. Now equate this expression to 0. Then only you will going to get the maximum value of the voltage. Am I clear? Any doubt in this? Alright. Now my dear friend, once you will going to equate this expression to 0, you will get X value as 0. Alright. So particularly at this value, your voltage will going to be maximum across the detector. So let us find Vd value at X equal to 0. So Vd at X equal to 0. So put X equal to 0 here. You will be having the value as 0. Done? Clear? Any doubt in this? So your correct answer is option D. And if you tick this one, you will going to get a negative marks. You will going to get a negative marks. Why, sir? Why I will going to get, or why you will going to get the negative marks? The reason is that here the range is given as minus 1.5 to 1.5, and we have not checked the voltage Vd at this point as well. So from the concept of a limit, or you can say from the concept of the limit from the mathematics subject, whenever the range is given to you and it is asking the maximum value, then you should also find the maximum value at this two end point or extreme point. Okay, means we have to find the value at the X equal to 0 also, means this is the extreme value, and we also need to find the value of Vd at the end point as well. Am I clear? So let us find the Vd at X equal to minus 1.5. So we have E X square is what? Minus 1.5 whole square. Let me see the expression first. Vd minus 1.5 whole square 4 minus x square. What is ER? E is 1 sin 314t. So E is 1 sin 314t into minus 1.5 is 2.25, means whole square 4 minus 2.25. So once you going to solve this, you will get the value as, let me write directly, 9 by 7. 9 by 7, 340t. Done. So here Vd at x equal to minus 1.5. I am getting the maximum value as 9 by 7. Alright, now let us find the value at Vd at x equal to 1.5. So again, substitute 1.5 here, 1 sin 314t, x as 1.5 whole square upon 4 minus 1.5 whole square. So this value will become again the 9 by 7 sin 340t. So from here the maximum value of Vd will be what? 9 by 7. So we need to check the value. Very nice session. Thank you, Jay Prakash. Means we need to check the Vd value at the end point as well as at the extreme point. And on comparing on those three values, we will going to identify the maximum value. So the correct answer is not the 0. The correct answer is what? 9 by 7 volt, which is given in the option B. Am I clear? Is this concept clear? Any doubt in this? JP, Vipin, Rupesh, Ankit, Pragya, Pratik. All right. Shall we move ahead? Let us go to the next question. All right. Take this question and this will be the homework question for you. I will reveal the answer. I will reveal the answer in the next session. That is on tomorrow. Am I clear? So take a screenshot on a count of 5. 1, 2, 3, 4, 5. Done. And I want each and every one of you to at least attempt this question. Okay. Here one concept is needed from the network, that is substitution method. If you know the substitution method, you will have your answer at your fingertip. All right. So let us move ahead with the next question, which is this one, and this is the last question of the today's session. All right. Now this is MSQ type of question. The question is, which of the following equation can be derived from the AC bridges shown in the figure 1 and figure 2? Assume del L by L equal to 0.1, R equal to j omega L, and 4 is greater than 0.1 square, which is equal to 4. Am I clear? So this is figure 1 and this is figure 2. And option is given to us like this. And we need to find which of the following options are matching with my solution. All right. So first, see this assumption part, and after that we will go to the solution. Okay. All right. So this is the figure 1. What I need to do? I need to find this V01. All right. I need to find the V01. Let me assume the current here is I1, here as I2. Done. So apply KVL. In that loop, V01 will be equal to what? This I2 into R minus I1 times j omega L plus minus del L. If you are having any doubt, then please let me know. So I2 will be what? This I2 is the current which is flowing across this, which is flowing through this branch, na? Flowing through this branch. So this I2 will be equal to Vs, the total voltage Vs whole divided by 2R into this resistor R minus I1 will be what? The same, Vs upon total impedance. So j omega L plus minus del L plus j omega. This is L minus plus del L, and here we have j omega L plus minus del L. Done. So Vs upon 2 we have this value. All right. What else? J omega and j omega will be cancelled out. So we are left with Vs L plus minus del L, and here L plus L. Sorry, here L plus minus del L plus L minus plus del L. Okay. So Vs by 2 minus Vs L plus minus del L. Now look at here, everybody. If you take the positive, if you take the positive sign from here, which is at the top of this 2 value, which is at the top, then from here we will have to select the negative value because this is at the top. So if you take the top value, or also not a value, top sign, then here we also have to select the top sign. If you take the what to say, the bottom sign, then from here we also have to take the bottom sign. You cannot take top and bottom at the same time. You cannot take top and bottom, or else bottom and top at the same time. If you take top from here, then we will have to pick top from here. So for that particular reason, this L and L will become 2L, and del L will be cancelled out, because if you take plus del L, here we need to take minus del L. If you take minus del L, here we will have to take plus del L. So del L will be cancelled out. So once you solve this, this will become Vs by 2 minus Vs by 2. Now look at here, this minus and plus will become minus, isn't it? Minus and plus will become minus. Minus and minus will become plus. So this will become minus plus Vs del L by L. So this will going to be cancelled out. All right. So V01 will be equal to minus plus Vs. What is del L by L? Sorry, here I left 2. 2 will come also, na? So what is del L by L? This is given as 0.1 whole divided by 2. So this will become minus plus Vs by 20. Let me check the option first. Okay. So here minus plus I have left. Here again minus plus I have left. And here minus plus. Done. So I got the value of V01 as minus plus Vs by 2. Now let us move to figure 2. Alright. Now apply the KVL in this loop. Alright. So V02 will be equal to what? Let me take this current as IB and this current as IA. So this will be IB into R minus IA into R. Done. What is IB? IB is total voltage, which is Vs, na? Vs upon total impedance R plus j omega L plus minus del L minus what? Sorry, into R, this R, minus what is IA? IA will be Vs upon R, this branch R plus j omega L minus plus del L into this resistor. All right. Now, one assumption is given to us that we need to assume R equal to j omega L. So replace R with j omega L. So into j omega L upon j omega L plus j omega L plus minus j omega del L. Here minus Vs, R is j omega L plus j omega L from this part, plus minus is minus, plus is plus. All right, here j omega del L. So j omega will be cancelled out from here as well. J omega will be cancelled out, and we are left with Vs times L, here 2L plus minus del L minus Vs L 2L minus plus del L. All right, done. So what we can do, divide this L from numerator and denominator. So we will get the expression as Vs upon 2 plus minus del L by L minus Vs upon 2 minus plus del L by L. Now del L by L is given us as Vs upon 2 plus minus 0.1 minus Vs upon 2 minus plus 0.1. Let me check guys. Del L by L, this is plus minus, here minus plus. Okay. Oh, so what we can do, let us take out Vs common. We are left with 1 upon 2 plus minus 0.1 minus 1 upon 2 minus plus 0.1. So take the LCM, 2 minus plus 0.1, this negative sign, 2 plus minus 0.1. Now look at here, if you take plus sign from here, sorry, this will become 0.1 like this. We have taken LCM now. So Vs, so this will become 2 minus plus 0.1, here minus 2. This minus and plus will become minus, minus and minus will become plus. This will be 0.1. Now look at here everybody. रुपेश कुमार सर EMT का क्लास कब होगा? शेड्यूल में EMT नहीं है. I don't know about that, Rupesh. Please be focused here. Please be focused here. If you take the plus sign, from the top, then from here you will have to take a negative sign. So this will become basically what? A plus B, A minus B ka whole square, isn't it? This will become A plus B and A minus B ka whole square. So this will be 2 square minus 0.1 ka whole square. Done. So this will be equal to Vs. This 2 and 2 will going to be cancelled out. This will become minus plus 0.2 whole divided by. This is 4 minus 0.1 ka whole square na? 4 minus 0.1 ka whole square. Now see the assumption. This is 4.1 ka whole square. So when these two are compared, this value is equal to 4, isn't it? This is given. All right, so this value will become 4. So when you solve this, this will become minus plus 0.2 by 4 is what? Divided by, this will become like this, sorry, minus plus Vs by 20. So here V01 is equal to V02, which is equal to minus plus Vs by 20. So in which option it is given? It is given in option B and option C and option, okay, option D is Vs. So option D is not correct. So the correct option for this question is option B and option D. All right. So how many of you have enjoyed this question? This question is very conceptual, and this question you have not yet seen in any test series. All right. Even I can say that in any other institute you have not ever seen this question. Okay, because this question has been framed by me only. All right, so this is a copyright question, so please do not copy this one. Okay, I am joking. All right, moving ahead. So hoping that you have got this solution part, and there are lot of a concept which is to be covered under this, which has been covered under this topic. All right, am I clear? Any doubt in this? Do we have any doubt? No? So this is the end of the session. Now let me give you the glimpse of the IMS GATE Academy. Means what things we are offering to the student. Okay. So this is the page. Once you will going to entered into our website, you will going to come across this page. Okay, after this, this is the program, this is the IMS program that we are offering: classroom program, hybrid program, exclusively live, and the self learning. All right. हाँ, मशीन भी मैं ही लूँगा फ्रॉम 8th of December onward, basically 8th of December and 9th of December. Okay, so this is the program that we are currently we have. All right, this is the classroom program in which we are offering 750 plus hour offline class session, which is 100% offline, and 20 to 30 books, theory exercise book we have, 4000 practice question, GATE question bank, doubt solving portal we have, my plan strategies, and the test series, which is 130 plus test series, and post GATE interview guidance. All right, so these all are given under the classroom program. Next, hybrid class program, all features are same. The only difference is we are offering 750 hours classroom program, in which 67% will be offline and the 33% will be online, including GATE online live classes. All right, you can take a screenshot also. Next is exclusively live online program, which is totally the online program. Here we don't have an offline concept. All right, and the rest will be same. Next, the self learning, in which the 400 plus hours of the video lecture are given to you. Let us move ahead. This is LPT methodology, which is adopted by the IMS team. First we learn, then practice, and then at last we test how our preparation mode is. All right, now moving ahead. This is the IMS GATE test series concept. Means we have this chapter subject wise, advanced level, multi subject, and the full length test. So you if you choose our test series course, then definitely you will going to have this sort of test. All right, so you can take a screenshot of this slides. Okay, let us move ahead. Again, we have a GATE at zero fee, so please enter into this website imsindia.com program/GATE ME. Here you will going to get /start. So once you will going to enter here, you will find this zero fee program. Means for this you will not have to pay any single penny. Am I clear? You will not have to pay any single penny, and for that you will have 100 plus hour of complete concept video, 12 chapter test, 6 subject test, and the 6 past GATE paper. All right, and this is absolutely free. That is the reason why we have zero fee. All right, moving ahead. This is a student portal where we will be having the GATE courses. All right, so once you have taken or once you have enrolled our once you have enrolled the program, you will going to have this sort of courses. All right, so under this you will be going to get the lectures and the PDF book and also the test series. All right, and these are the videos, lecture live and in the case of recorded. All right, moving ahead. This will be the doubt portal where the student posts their doubt, and we faculty used to clarify the doubt of the student within the 24 hours, like that. Okay, let us move ahead. So this is the my plan session where we used to conduct, means the IMS team used to conduct one-to-one session with the student, or one-to-many session with the student. Where we tell the student, or we help the student, or we guide the student in their preparation strategies, like that. Okay, so whenever the student get stuck or demotivated, they will plan a schedule like in this manner, in which we will going to have one-to-one session, and definitely the morale of the student will going to be at the peak level. All right, so this is one of the USP of the IMS GATE Academy. All right, so that is all about the today's session. So hope you have enjoyed the session, and if you have enjoyed the session, please like and share the session with a friend. So this is the end of the session 1. The session 2 will be conduct on tomorrow, and tomorrow we will going to see the leftover chapter from the measurement. All right, so guys, please do take care of your health and of your family, and because as you know that the gate exam is at the inching level, so we suggest you to please take care of your good health at the at very good level. All right, so let us end the session and we'll see you on tomorrow. All right, bye.